Welcome to a realm where the wild reigns supreme and every moment is a testament to the power and ingenuity of nature. Here in the vast stretches of savanna, the tangled depths of rainforests and the shadowy corners of deserts and swamps, life unfolds in a breathtaking display of survival and adaptation. As the sun dips below the horizon and the world shifts from day to night, a silent and thrilling battle for existence begins anew. In these wild places, every creature is locked in a constant struggle where only the most cunning, swift, or well-defended can hope to survive. This world is home to an astonishing array of life forms, each more extraordinary than the last. From the tiniest insects to the largest predators, every animal has carved out a unique niche, evolving remarkable traits to thrive in their environment. Some are true masters of disguise, blending seamlessly into their surroundings. The chameleon, for example, can change its skin color to match the foliage, while the stick insect becomes nearly invisible among twigs and branches. These adaptations are not just for hiding from predators, but also for ambushing unsuspecting prey. Others are built for speed and precision. The cheetah, the fastest land animal, can accelerate from 0 to 60 miles per hour in just a few seconds, while the peregrine falcon dives at over 200 miles per hour to snatch birds mid-flight. Even underwater, predators like the sailfish and barracuda rely on lightning-fast reflexes to catch their prey. But among the most formidable adaptations is venom, a potent biological weapon wielded by a surprising variety of creatures. From snakes and spiders to scorpions, centipedes, and even marine snails, venom has evolved independently across the animal kingdom as a means to subdue prey or deter attackers. Venom is a marvel of natural chemistry, capable of paralyzing, killing, or digesting prey with astonishing efficiency. Some venoms attack the nervous system, causing instant paralysis, while others break down tissues or disrupt blood clotting. The diversity and complexity of these toxins are a testament to millions of years of evolutionary arms races. In this world, every heartbeat matters. Prey animals must remain ever vigilant, their senses finely tuned to detect the faintest hint of danger. A single misstep can mean the difference between life and death. Yet, the story of the wild is not just about the hunters. For every predator, there is prey that has evolved its own arsenal of defenses, turning the tables in this endless contest. The mongoose, for instance, is renowned for its agility and resistance to snake venom, allowing it to challenge even the most dangerous serpents. Herd animals like zebras and wildebeest rely on numbers and coordinated movement to confuse and evade predators. Some animals have developed extraordinary physical and chemical defenses. The pangolin's armored scales can withstand the bite of a lion, while the porcupine's quills deter even the boldest attackers. Frogs and beetles secrete potent toxins, and some, like the bombardier beetle, can even spray boiling chemicals at their foes. The wild is a stage for dramatic confrontations and daring escapes. Whether it's a mongoose dodging a cobra's strike or a lizard sacrificing its tail to slip from a predator's grasp, every encounter is a test of skill and adaptation. Imagine the wild as a living, breathing action epic, where every chase, ambush, and standoff is the result of countless generations honing the art of survival. Each animal, from the smallest insect to the mightiest predator, plays a vital role in this intricate web of life. Social creatures like lions and wolves rely on teamwork and strategy, while ants and termites build vast colonies that function as superorganisms, capable of taking down much larger adversaries through sheer numbers and coordination. Throughout this journey, we will encounter apex predators, creatures that sit atop the food chain, commanding respect and fear. From the silent stalk of the jaguar to the calculated ambush of the orca, these animals are the ultimate expressions of evolutionary success. Prepare to meet snakes with fangs as long as your finger, capable of delivering venom that can kill in minutes. The Gaboon viper's fangs are the longest of any snake, while the king cobra's venom can bring down an elephant. Witness lizards like the Komodo Dragon, whose toxic bite and immense strength allow it to hunt animals many times its own size. Even smaller reptiles, such as the Gila monster, wield venom to subdue their prey. We will delve into the secrets of venom, how it is produced, delivered, and how it has shaped the destinies of both predator and prey. Each drop is a complex cocktail, fine-tuned for maximum effect. Discover the ingenious hunting strategies that have evolved, from the ambush tactics of snakes and spiders to the lightning-fast strikes of the mantis shrimp, whose punch is one of the fastest movements in the animal kingdom. Each predator uses its unique abilities, stealth, speed, strength, or venom, to dominate its environment and secure its place at the top. Imagine seeing the world through their eyes, the acute night vision of an owl, the heat-sensing pits of a viper, or the electroreception of a shark. These senses reveal a hidden world, where the faintest movement or vibration can mean the difference between feast and famine. Prepare to be astonished by the wonders and dangers that fill every corner of the wild. The adventure is just beginning, and the wild holds countless stories of courage, cunning, and survival. We will shine a light on the underdogs, the resilient survivors who use speed, armor, or clever tricks to escape the jaws of death. Some animals have developed immunity to the deadliest venoms, like the honey badger and the mongoose, while others rely on deception or sheer toughness to outlast their enemies. Teamwork is another powerful weapon. Wolves, dolphins, and even insects like ants and hornets use coordinated attacks to bring down prey much larger than themselves. Physical defenses can be just as effective. The turtle's shell, the porcupine's quills, and the armadillo's armor are all remarkable adaptations that force even the fiercest predators to reconsider their attack. This eternal dance between predator and prey is the engine that drives evolution, shaping the bodies, behaviors, and minds of every creature involved. The story of life in the wild is one of constant change and adaptation. As seasons shift and environments transform, animals must continually evolve new strategies to survive and thrive. Are you ready to journey deeper into this world of deadly wonders? Let us plunge into the heart of nature's most thrilling and dangerous secrets. Deep within the heart of Africa's rainforests, where the ground is thickly carpeted with fallen leaves and the air is heavy with moisture, a remarkable predator lies in wait. The forest floor here is a mosaic of browns, greens, and dappled sunlight, creating a perfect backdrop for one of nature's most elusive hunters. The Gaboon viper is a true master of camouflage, its body blending seamlessly with the leaf litter and debris. This snake is almost invisible, even to the sharpest eyes, as it remains motionless among the tangled undergrowth. Its scales are adorned with intricate geometric patterns in shades of pink, purple, and brown, perfectly mimicking the dead leaves and shadows of the rainforest floor. This extraordinary coloration is not just for beauty, it is a vital adaptation for survival. The Gaboon viper's hunting strategy is built on patience and stealth. It will remain completely still for days, sometimes even a week, waiting for the vibrations of a passing animal to signal the perfect moment to strike. As the heaviest viper in Africa, the Gaboon viper can weigh over 8 kilograms and reach lengths of up to 2 meters. Its robust, muscular body is designed for ambush rather than pursuit, allowing it to conserve energy while waiting for prey. The head of the Gaboon viper is broad and triangular, with a pair of strikingly large eyes and horn-like scales above the nostrils. These features help break up its outline, enhancing its camouflage even further. Perhaps its most formidable adaptation is its fangs, the longest of any snake on Earth, reaching up to 5 centimeters. These needle-sharp fangs are perfectly engineered to penetrate deep into prey. The fangs are hollow, functioning like hypodermic needles to deliver venom with incredible efficiency. When the viper strikes, its jaws open nearly 180 degrees, allowing the fangs to swing forward and inject venom deep into the target. The Gaboon viper's strike is both swift and precise. It relies on the element of surprise, launching its attack with explosive speed and accuracy, often catching prey completely off guard. The venom itself is a complex cocktail of cytotoxins, hemotoxins, and neurotoxins. Cytotoxins destroy cells and tissues, causing rapid swelling and tissue damage. Hemotoxins disrupt blood clotting and can lead to internal bleeding, while neurotoxins interfere with nerve signals, quickly immobilizing the prey. This potent combination ensures that the prey is subdued quickly and efficiently, minimizing the risk of escape or injury to the viper. Despite its deadly arsenal, the Gaboon viper is remarkably calm and deliberate in its movements. It rarely wastes energy, moving only when absolutely necessary. Its diet is diverse, including rodents, birds, frogs, and even small antelopes. The viper's slow metabolism allows it to go weeks or even months between meals, making each successful hunt crucial for survival. After delivering a fatal bite, the Gaboon viper waits patiently for the venom to take effect before beginning the slow process of swallowing its prey whole, aided by flexible jaws and powerful muscles. In the complex web of the rainforest ecosystem, the Gaboon viper plays a vital role as a top predator. By controlling populations of rodents and other small mammals, it helps maintain the delicate balance of the forest. Its presence ensures that prey species do not become overabundant, which could otherwise lead to overgrazing and habitat degradation. The Gaboon viper's patience is legendary. It can remain motionless for extraordinary lengths of time, conserving energy and waiting for the perfect opportunity to strike. This ability to wait, sometimes for an entire week, is a testament to its adaptation as an ambush predator in a challenging environment. The Gaboon viper's life is one of stillness and subtlety, perfectly attuned to the rhythms of the rainforest. Its slow, deliberate movements and acute sensory perception allow it to detect the faintest vibrations and scents, guiding it to potential prey. By conserving energy and striking only when success is almost certain, the Gaboon viper exemplifies the efficiency of ambush predation. The Gaboon viper stands as a stunning example of evolutionary perfection, a silent, patient, and deadly guardian of the African rainforest, essential to the health and balance of its wild domain. Journey with us into the heart of North America's arid deserts, where the landscape is shaped by relentless sun and shifting sands. Here, the western diamondback rattlesnake reigns as one of the most formidable predators, perfectly attuned to the extremes of its environment. Its skin, adorned with a pattern of dark diamonds and sandy hues, allows it to vanish against the desert floor. This camouflage is not just for hiding from larger predators, but also for stalking unsuspecting prey. The western diamondback's signature feature is its rattle, a series of hollow, interlocking keratin segments at the tip of its tail. When threatened, the snake vibrates its tail at remarkable speeds, producing a sharp, buzzing warning that echoes across the desert. This rattle is a sophisticated defense mechanism, evolved to deter would-be predators and signal its presence to larger animals that might pose a threat. As a pit viper, the western diamondback possesses a remarkable adaptation: heat-sensing pits located between its eyes and nostrils. These specialized organs detect the faintest traces of infrared radiation, allowing the snake to form a thermal image of its surroundings and pinpoint the body heat of prey, even in total darkness. This ability transforms the western diamondback into a master nocturnal hunter, capable of tracking warm-blooded animals like mice, rats, and rabbits as they scurry through the cool desert night. Whether under the blazing sun or beneath the stars, the rattlesnake's ambush tactics are legendary. It lies motionless, coiled and ready, waiting for the perfect moment to strike. Patient and precise, it often positions itself near well-traveled animal trails, blending seamlessly into the brush and sand, conserving energy until prey comes within range. The coolness of dusk and night offers the western diamondback a strategic advantage, allowing it to avoid the harshest heat while maximizing its hunting opportunities. When the moment arrives, the strike is a blur of speed, one of the fastest in the animal kingdom. The snake launches forward, fangs bared, in a fraction of a second. Its long hinged fangs penetrate deeply, delivering a precise dose of venom directly into the prey's bloodstream. The venom is a powerful hemotoxin, designed to disrupt blood flow, destroy tissue, and incapacitate the prey rapidly. Unlike neurotoxins, which paralyze, hemotoxins cause internal bleeding and begin the process of digestion from within. As the venom takes effect, the prey weakens and succumbs, its internal systems overwhelmed by the destructive power of the toxin. The western diamondback often releases its prey after the strike, relying on its highly sensitive forked tongue to follow the scent trail left behind, tracking the dying animal through the desert. Once located, the snake performs an extraordinary feat, unhinging its jaws to swallow prey much larger than its own head, aided by flexible ligaments and powerful muscles. The western diamondback is a keystone species, maintaining balance in the desert ecosystem by regulating populations of small mammals and other prey. By preying on rodents, it prevents overpopulation, which could otherwise devastate the fragile desert vegetation and disrupt the food web. Without this natural control, rodents would consume vast amounts of seeds and plants, threatening the survival of countless other desert species. The rattlesnake's predatory role also limits the spread of diseases among wild rodent populations, further supporting the health of the ecosystem. With each shed of its skin, a new segment is added to its rattle, a living record of its growth and survival in the harsh desert. The western diamondback rattlesnake stands as a symbol of adaptation and resilience, a true survivor in one of the world's most unforgiving environments. Deep within the sun-baked grasslands and rocky outcrops of sub-Saharan Africa, a legendary predator glides silently through the undergrowth. The Black Mamba, Dendroaspis polylepis, is a creature shrouded in myth and awe, renowned for its astonishing speed, potent venom, and commanding presence in the wild. Among the world's longest venomous snakes, the Black Mamba can reach lengths exceeding 4 meters, making it a formidable figure in the African bush. It is celebrated as the fastest land snake on Earth, capable of slithering at speeds up to 20 kilometers per hour, an extraordinary feat for a reptile. This speed allows the Black Mamba to traverse vast territories in search of prey and evade larger predators with remarkable agility. Despite its name, the Black Mamba's skin is typically a muted grayish-brown, blending seamlessly with the dusty earth and dry grasses of its environment. The name Black Mamba comes from the inky black coloration inside its mouth, a feature it displays as a stark warning to would-be threats. This open-mouthed display is a powerful deterrent, signaling the snake's readiness to defend itself with lethal force if necessary. Unlike ambush predators that wait patiently for prey, the Black Mamba is an active hunter, constantly on the move. It glides through the savanna with its head raised high, scanning the landscape with keen eyesight. Its vision is exceptional, allowing it to detect the slightest movement of potential prey such as birds, squirrels, and small mammals. The Black Mamba also relies on its acute sensitivity to ground vibrations, picking up the faintest tremors produced by scurrying animals. This dual sensory approach makes it a highly efficient predator, able to locate prey even when it is hidden from view. When the Black Mamba identifies a target, it strikes with lightning speed and surgical precision. It can lift up to a third of its body off the ground, extending its reach and enabling it to deliver multiple rapid bites in a single attack. This striking range, combined with its speed, makes it nearly impossible for prey to escape once targeted. The Black Mamba's venom is a potent blend of neurotoxins, designed to immobilize and kill with astonishing efficiency. Once injected, the venom rapidly disrupts the nervous system, causing paralysis and respiratory failure in a matter of minutes. The swift action of the venom ensures that prey cannot escape or retaliate, allowing the snake to feed safely. In the wild, this rapid immobilization is crucial, as the Black Mamba often hunts agile and fast-moving animals. Its venom acts as both a weapon and a tool for survival, ensuring that its meals are subdued before they can escape into the dense brush. The Black Mamba's predatory tactics are a masterclass in efficiency: locate, strike, and subdue, all within seconds. Once the prey is immobilized, the snake swallows it whole, using its flexible jaws to consume animals much larger than its head. After a successful hunt, the Black Mamba may rest and bask in the sun, digesting its meal and conserving energy for its next pursuit. The Black Mamba is highly adaptable, thriving in a range of habitats, from open savannas to dense woodlands and rocky hillsides. As a top predator, it plays a vital role in controlling populations of small mammals and birds, maintaining balance within its ecosystem. Despite its fearsome reputation, the Black Mamba is naturally shy and elusive, preferring to avoid confrontation whenever possible. Its first instinct is to flee at the slightest sign of danger, using its speed to disappear into the safety of the undergrowth. Only when cornered or threatened does it display aggression, rearing up and exposing the black interior of its mouth as a final warning. If escape is impossible, the Black Mamba will defend itself with a series of rapid, accurate strikes. This dramatic display is a last resort, a clear signal to any would-be attacker of the danger they face. Most animals instinctively recognize this warning and retreat, leaving the Black Mamba unchallenged. The Black Mamba is the embodiment of speed, precision, and lethal efficiency, a true marvel of evolution. As a dominant predator, it shapes the ecosystem around it, ensuring the health and balance of the African wilderness it calls home. Our journey now takes us to a remote chain of islands in Indonesia, where a true giant of the reptile world reigns supreme. Here, in the sun-baked forests and rugged hills, lives the largest lizard on Earth, a creature so formidable it has inspired legends for centuries. This is the Komodo Dragon, a living relic from a prehistoric age. These colossal reptiles can reach lengths of up to 3 meters and tip the scales at over 90 kilograms, making them the undisputed apex predators of their island domain. With muscular bodies, powerful limbs, and jaws lined with serrated teeth, Komodo dragons are built for the hunt. Masters of stealth, they use their muted coloration to blend seamlessly into their surroundings, lying in wait for unsuspecting prey to wander close. When the moment is right, the Komodo dragon explodes into action, launching a sudden and devastating attack. Its bite is not only powerful, but also uniquely lethal. Unlike most reptiles, the Komodo dragon possesses venom glands in its lower jaw, which deliver a complex cocktail of toxins with every bite. This venom rapidly lowers blood pressure, induces shock, and prevents blood from clotting, causing the victim to weaken and collapse. Even a single bite can be fatal, as the toxins work in tandem with deep wounds to ensure the prey cannot escape for long. Large animals such as deer, wild boar, and even water buffalo are often brought down by this deadly combination. If the prey manages to flee, the Komodo dragon's strategy is patience. The venom continues to weaken the animal, causing it to stagger and slow. The dragon follows at a distance, tracking its quarry with relentless determination. Thanks to its extraordinary sense of smell, the Komodo dragon can locate a wounded animal from several kilometers away, using its long, forked tongue to sample scent particles in the air. Once the prey collapses, the Komodo dragon moves in, using its powerful jaws and sharp claws to tear through flesh and bone with ease. Their sense of smell is so acute they can detect the scent of blood or carrion from over 4 kilometers away, making them efficient scavengers as well as hunters. The Komodo's tongue is a vital tool, flicking in and out to gather chemical cues from the environment. By analyzing these particles with a specialized organ in the roof of its mouth, the dragon can pinpoint the location of prey or carrion with remarkable accuracy. This adaptation allows them to patrol vast territories, always alert for the faintest trace of a meal. Komodo dragons are solitary wanderers, covering great distances in search of food, water, and mates. Despite their massive size and lumbering gait, they are capable of sudden bursts of speed, reaching up to 20 kilometers per hour to ambush prey. Their muscular tails provide balance and power, while their strong legs propel them forward in a surprising sprint. Young Komodo dragons are agile climbers, escaping danger by scaling trees, and all ages are strong swimmers, able to cross between islands in search of new territory. Their hunting methods are a blend of patience, power, and precision, waiting in ambush, stalking through undergrowth, or scavenging from the remains of other kills. These remarkable adaptations have allowed the Komodo dragon to dominate its environment for millions of years. Yet, despite their prowess, Komodo dragons are now found only on a handful of Indonesian islands, with just a few thousand individuals remaining in the wild. Their range is limited to just 5 islands, where they continue to rule as top predators. In these isolated habitats, they play a crucial role in maintaining the balance of their ecosystems. Every aspect of the Komodo dragon, from its venomous bite to its acute senses and formidable strength, is a testament to the power of evolution. These living dragons are a precious and irreplaceable part of our planet's natural heritage. Their story is a powerful reminder of the wonders of adaptation, survival, and the delicate balance of life in the wild. The Komodo dragon stands as a symbol of nature's ingenuity and the incredible diversity of life on Earth. As the sun sets over the islands, the mighty Komodo continues its ancient patrol, a living legend and a reminder of the wild world we must strive to protect. So far, we've met some of the world's most effective hunters, armed with camouflage, speed, and deadly venom. But the wild is not a one-sided battlefield. For every venomous predator, there are prey animals that have evolved astonishing ways to fight back, sometimes turning the tables on their would-be killers. The story of survival in the wild is as much about defense as it is about attack. Prey animals are not helpless victims. They are masters of adaptation, constantly evolving new strategies to outwit, outlast, and even outfight their venomous foes. Camouflage is one of the first lines of defense. By blending seamlessly into their surroundings, prey animals like deer and rabbits can avoid detection by venomous snakes and other predators, making the hunt far more challenging. But when camouflage fails, the arms race intensifies. Predators develop more potent venom or stealthier hunting tactics, while prey counter with new defenses, sometimes physical, sometimes chemical, and sometimes even behavioral. Some prey animals have evolved physical armor that can thwart even the most determined venomous attacker. These adaptations are so remarkable they seem almost superpowered. This ongoing struggle for survival is what keeps the natural world in a state of dynamic, ever-shifting balance. Take the porcupine, for example. Its armor is a dense coat of sharp, barbed quills, an ingenious defense against venomous and non-venomous predators alike. This slow-moving rodent would be an easy meal for predators like leopards or pythons, if not for its secret weapon, thousands of quills, each tipped with microscopic barbs. These quills are actually modified hairs, designed to detach at the slightest touch. When a predator strikes, the quills embed deeply, causing pain and injury. The porcupine will often turn its back and charge, driving the quills into the attacker's face or paws. The barbs make removal nearly impossible, and the wounds can become infected, sometimes fatally so. For venomous predators, a mouthful of quills can mean the end of the hunt, and sometimes the end of the predator itself. The lesson is clear. Attacking a porcupine is a gamble that rarely pays off. But not all defenses are physical. Some prey animals have developed chemical countermeasures that are just as effective. The Japanese honeybee is a master of this strategy. The Asian giant hornet, with its potent venom and powerful jaws, is a nightmare for most bees. A single hornet can decimate a hive in minutes, but Japanese honeybees have evolved a unique defense that uses heat as a weapon, rather than venom or stings. When a hornet scout enters the hive, hundreds of bees swarm it, forming a living ball that traps the invader. The bees then vibrate their flight muscles rapidly, generating intense heat and carbon dioxide within the ball. The temperature inside the ball rises to 47 degrees Celsius, enough to kill the hornet, but not the bees, who can tolerate slightly higher heat. The hornet is literally cooked alive, neutralizing the threat before it can summon reinforcements. Some prey animals have taken the fight to a whole new level by evolving resistance to venom itself. This biological arms race has produced some of the most remarkable adaptations in the animal kingdom. The long-eared hedgehog, a small desert dweller, is a prime example. This tiny mammal doesn't just avoid venomous snakes, it actively hunts them, including deadly cobras. The secret lies in its blood. The long-eared hedgehog has evolved proteins that neutralize snake venom, rendering bites that would kill other animals harmless. With this immunity, the hedgehog can attack again and again, biting the snake's spine until it is paralyzed and no longer a threat. In a stunning reversal, the predator becomes the prey, and the hedgehog enjoys a meal that would be deadly for most. These extraordinary defenses, armor, chemical warfare, and venom resistance, prove that in nature, survival is not just about strength or size, it's about innovation, adaptation, and the relentless will to fight back against even the deadliest of foes. Some predator-prey battles are so famous they have become legendary. In the wild, these epic confrontations are not just about brute strength, but about cunning, speed, and the remarkable adaptations that have evolved over countless generations. One of the most classic showdowns in the animal kingdom is the fight between the mongoose and the cobra, or its equally formidable cousin, the Black Mamba. These encounters are a true test of nerve and skill, with both animals relying on their unique abilities to survive. The mongoose, though small and furry, is a giant slayer when it comes to snakes. Its body is built for speed and agility, with sharp senses that allow it to detect the slightest movement in the grass. When a black mamba or cobra strikes, the mongoose reacts in a split second, dodging with lightning-fast reflexes. It reads the snake's body language, anticipating the direction and timing of each strike. The mongoose circles its opponent, weaving and feinting, never staying in one place for long. This relentless movement confuses and exhausts the snake, forcing it to expend precious energy with every failed attack. It is a true master of agility and strategy, using its nimble body to stay just out of reach while searching for an opening. But speed alone isn't enough to take on a black mamba, whose venom can kill a much larger animal in minutes. The mongoose has another trick up its sleeve, a biological superpower that gives it a fighting chance against even the deadliest snakes. Specially shaped receptors in its body prevent the snake's neurotoxin from locking onto its nervous system. This adaptation means that, while not completely immune, the mongoose is highly resistant to venom. The black mamba's fangs deliver a dose of venom designed to paralyze and kill, but the mongoose's resistance allows it to survive bites that would be fatal to most creatures. Even if bitten, the mongoose often shakes off the effects, continuing the fight with undiminished ferocity. With the snake exhausted and distracted, the mongoose seizes its moment. In a blur of motion, it lunges forward, delivering a single precise bite to the back of the snake's skull, crushing it instantly and ending the battle. But snakes face danger from more than just ground-dwelling predators. They must also keep a wary eye on the sky, where another set of lethal hunters awaits. Birds of prey, like the secretary bird and the serpent eagle, are specialized snake hunters, each with their own arsenal of adaptations for tackling these dangerous reptiles. The secretary bird, with its long legs and powerful feet, stalks snakes across the savanna, striking with rapid, bone-crushing kicks that can kill a snake in seconds. The serpent eagle, meanwhile, soars above the forest, scanning for movement before swooping down in a sudden deadly attack. Both birds have legs covered in thick, tough scales, natural armor that shields them from venomous bites as they grapple with their writhing prey. The serpent eagle even sports hardened eyelids, a unique adaptation that protects its eyes from desperate strikes during the struggle. Once the bird has subdued the snake, it may grab it with razor-sharp talons and take to the air, carrying its prize away from other predators. Perched safely, the eagle prepares to eat. But even now, the battle isn't over. The way the eagle consumes its prey is a testament to evolutionary ingenuity. The eagle swallows the snake head first, a crucial tactic that ensures the snake's backward-pointing scales lie flat, allowing it to slide smoothly down the bird's throat. If the bird tried to swallow the snake tail first, the scales would catch, making the meal dangerous and potentially deadly. By swallowing head first, the eagle avoids this risk, demonstrating the importance of even the smallest details in the struggle for survival. Any mistake could mean the difference between a successful hunt and a fatal error. These incredible battles, whether between mongoose and mamba on the ground, or eagle and snake in the sky, are the result of millions of years of co-evolution. Each animal has honed its tactics and adaptations, pushing the other to become stronger, faster, and smarter. In the wild, every encounter is a test of survival, and only the most skilled emerge victorious. The world is full of creatures with extraordinary abilities that help them survive in their unique environments. Some of the most astonishing superpowers in the animal kingdom are related to venom and defense, nature's ultimate tools for survival. These adaptations are like real-life superpowers, honed over millions of years of evolution, allowing animals to hunt, defend, and thrive in even the harshest conditions. In the deserts of Africa, we find the caracal, a medium-sized cat also known as the desert lynx. It has long black tufts on its ears that act like antennas, amplifying sounds and helping it pinpoint the location of its prey with incredible accuracy. But its most spectacular skill is its vertical leap. A caracal can jump more than 3 meters straight up into the air to snatch birds right out of the sky. It's an acrobatic feat that makes it a master bird hunter. Even creatures that seem small and harmless can be hiding a deadly secret. In South America lives a caterpillar called the Lonomia obliqua, or the killer caterpillar. Its body is covered in spines that look like a tiny, fuzzy Christmas tree. But these spines are not for show. They are hollow needles, filled with one of the most potent venoms in the natural world. This venom contains powerful anticoagulants that prevent blood from clotting. A single light touch is enough to inject a powerful anticoagulant that stops blood from clotting. This can cause massive internal bleeding, kidney failure, and can even be fatal to humans. It's a powerful reminder to never judge a creature by its size. Take the poison dart frog, for example. These tiny amphibians secrete batrachotoxin through their skin, a chemical so potent that just a few micrograms can paralyze or kill much larger animals. This toxin blocks nerve signals, making it a highly effective defense against predators. The Namib Desert is one of the hottest and driest places on Earth, yet it is teeming with life. Here, the Peringues adder, a type of viper, has developed a unique way of moving across the scorching hot sand. It moves sideways in a motion called side-winding, which keeps most of its body off the ground at any given time to avoid getting burned. In the ocean, the cone snail wields a venomous harpoon. Its modified tooth acts as a hypodermic needle, injecting a cocktail of neurotoxins that can paralyze fish almost instantly. Scientists study these toxins for their potential in pain relief and medicine. The oryx antelope, which also lives in this region, can survive by allowing its body temperature to rise to an incredible 45 degrees Celsius, a temperature that would be fatal for most other mammals. The bombardier beetle has a remarkable chemical defense. When threatened, it mixes 2 chemicals in its abdomen, creating a boiling, noxious spray that is ejected at predators with a loud pop. This rapid chemical reaction can reach nearly 100 degrees Celsius, deterring even the most persistent attackers. These incredible adaptations are not limited to hunting or defense. The beautiful stripes of the Hartmann's mountain zebra are not just for show. They serve multiple purposes. The confusing pattern makes it difficult for a predator like a lion to single out one individual from a running herd. The stripes also help to regulate the zebra's body temperature, with the black stripes absorbing heat in the morning and the white stripes reflecting it during the heat of the day. The Malaysian exploding ant takes defense to the extreme. When threatened, it contracts its abdominal muscles so forcefully that its body ruptures, spraying a sticky, toxic substance at attackers. This self-sacrifice protects the colony from invaders. Every creature, from the tiniest insect to the largest mammal, has a unique set of tools, venom, armor, camouflage, or chemical warfare that allows it to survive and thrive in its part of the world. Nature's arsenal is as diverse as it is astonishing. Across the vast rainforests, sun-scorched deserts, and isolated islands, nature weaves a complex web of life. Every creature, from the smallest insect to the most formidable predator, plays a vital role in maintaining the delicate equilibrium of their ecosystem. We have witnessed the relentless pursuit of hunters and the ingenious defenses of survivors, each interaction shaping the world around them. Venomous predators like the Gaboon viper, rattlesnake, and Black Mamba are not just fearsome, they are essential. Their venom is a finely tuned tool, honed by evolution, that allows them to hunt efficiently and defend themselves in a world of constant competition. The Komodo Dragon's venom, for example, helps it subdue large prey, ensuring that only the fittest animals survive and that resources are not depleted too quickly. Meanwhile, prey species have evolved remarkable defenses, spines, stingers, and armor that keep predator numbers in check and drive the evolution of new hunting strategies. The Mongoose's legendary courage against venomous snakes is just one example of how the balance of power is constantly shifting, fueling an evolutionary arms race. Each adaptation, whether offensive or defensive, is a piece of a much larger puzzle, the intricate balance of nature. This balance is what allows ecosystems to thrive, supporting a dazzling array of life forms and maintaining the health of the planet. The ongoing struggle between predator and prey is not a battle of good versus evil, but a natural process that keeps populations in check and prevents any one species from overwhelming the system. Venomous predators in particular are crucial for this balance. By controlling populations of rodents, insects, and other prey, they prevent overgrazing, disease outbreaks, and habitat destruction. They also act as nature's cleanup crew, removing the weak, sick, or dead, and recycling nutrients back into the ecosystem. Without these predators, prey populations could explode, leading to the collapse of plant communities and a loss of biodiversity. Venomous snakes, for instance, are vital in controlling rodents and other small mammals, which, if left unchecked, can devastate crops and spread disease. The absence of these predators can trigger a cascade of negative effects, unraveling the fabric of the ecosystem. On isolated islands, Komodo dragons keep populations of large herbivores in check, preventing overgrazing and ensuring the survival of plant life. Predators often target the weak, sick, or old, strengthening prey populations by allowing only the healthiest to survive and reproduce. This natural selection ensures the resilience and adaptability of entire species, contributing to the rich tapestry of biodiversity. The result is a vibrant, dynamic ecosystem where every species, from the tiniest insect to the largest predator, has a role to play. Prey animals, too, are vital. Their defenses limit predator success, preventing overhunting and ensuring that no single species dominates. If predators succeeded every time, prey would vanish, and the predators themselves would soon follow. The constant challenge of survival keeps both predator and prey populations in balance. When this balance is disrupted, entire ecosystems can collapse, leading to barren landscapes and the loss of countless species. The struggle for survival is what keeps nature healthy, diverse, and ever-changing. Ingenious defenses like the hedgehog's spines or the porcupine's quills ensure that hunting is never easy, driving predators to adapt and evolve. This ongoing contest of adaptation, known as co-evolution, is a powerful engine of biodiversity. Over generations, it produces new forms, behaviors, and relationships, enriching the natural world with endless variety. Venomous predators, in particular, are at the heart of this process, driving innovation and resilience in the species they interact with. They are not monsters, but masterpieces of evolution, perfectly adapted to their roles in the web of life. Their presence ensures the health, diversity, and resilience of the ecosystems they inhabit. Together, predator and prey form the foundation of the great circle of life, each dependent on the other for survival. Their interactions create the dynamic, ever-changing world that supports all life on Earth. The balance of nature is both fragile and magnificent, a testament to millions of years of evolution and adaptation. By understanding the roles of venomous predators and the intricate connections between all living things, we can truly appreciate the wild, wonderful, and sometimes deadly world we all share. These natural dramas are not just spectacles, they are the heartbeat of our planet, driving its diversity and ensuring its survival for generations to come. Beneath the shimmering surface of the world's oceans lies another realm of venomous wonders, where the hunters are silent, the defenses are invisible, and the stakes are just as high. Here, among coral reefs and swaying seagrass, some of the planet's most toxic creatures glide, drift, and hunt with lethal precision. The box jellyfish, with its ghostly, translucent bell and delicate tentacles, is one of the ocean's most notorious predators. Each tentacle is lined with thousands of microscopic harpoons, called nematocysts, capable of delivering venom in a fraction of a second. This venom is among the most potent on Earth, instantly paralyzing small fish and crustaceans, allowing the jellyfish to reel in its prey with ease. The box jellyfish's venom doesn't just immobilize, it starts digesting its catch before it even reaches the mouth, demonstrating a gruesome efficiency unique to the marine world. Lurking on sandy sea floors and among coral rubble, the cone snail is another master of chemical warfare. Despite its slow movements, this unassuming mollusk is a formidable hunter. When prey approaches, the cone snail fires a hollow, harpoon-like tooth loaded with a cocktail of venom. This venom contains a complex mix of toxins, each targeting nerves and muscles in a different way. Some cone snail venoms act in seconds, shutting down the prey's nervous system and ensuring a meal with no struggle. The diversity of their toxins has made cone snails a focus of scientific fascination, as each species produces a unique blend, perfectly tailored to its hunting needs. And then, hidden in plain sight among the shells and rocks, the blue-ringed octopus awaits. Small enough to fit in the palm of your hand, this octopus is instantly recognizable by the iridescent blue rings that flash across its body when threatened. Its venom is a potent neurotoxin called tetrodotoxin, strong enough to immobilize prey almost instantly. The blue-ringed octopus hunts small crustaceans and fish, using its beak to deliver the venom directly, ensuring there is no escape. Unlike many predators, it relies on stealth and surprise, blending into its surroundings until the perfect moment to strike. Each of these marine predators plays a crucial role in their ecosystems. By controlling populations of fish, crustaceans, and mollusks, they help maintain the delicate balance of the ocean's food web. Their venom is not only a tool for survival, but a driving force in the evolutionary arms race beneath the waves. Prey species develop thicker shells, faster escape responses, and even chemical defenses of their own, fueling a cycle of adaptation that shapes the diversity of life in the sea. In the silent world of the ocean, venomous hunters like the box jellyfish, cone snail, and blue-ringed octopus are masterpieces of evolution, perfectly tuned to their environments and essential to the health of marine ecosystems. Their stories remind us that the wonders of venom are not confined to the land. They pulse through every tide, every current, and every hidden corner of the blue planet. Deep within the tangled roots of rainforests and the sunlit fields of grasslands, a miniature war rages, one fought not with claws or fangs, but with venom delivered in the smallest of doses. Here, Insects have evolved chemical arsenals as sophisticated and deadly as any predator in the animal kingdom. Consider the bullet ant, reigning in the humid forests of Central and South America. At first glance, it looks like any other large ant, but beneath its armored exoskeleton lies one of the most potent stings in the insect world. The bullet ant's venom contains a neurotoxic peptide called neurotoxin. When injected, it overwhelms the nervous system of its targets, paralyzing small prey and deterring would-be predators. For any creature on the receiving end, the pain is immediate, intense, and unforgettable. This powerful defense makes the bullet ant a force few dare to challenge, ensuring its colony's survival amidst countless threats. High above, in the paper-thin nests suspended from branches, wasps patrol their territories with a different kind of venom. Their stings deliver a complex blend of enzymes, peptides, and amines designed to immobilize prey and defend their young. For the insect prey, the venom causes rapid paralysis by disrupting cell membranes and nervous signals, allowing wasps to feed their larvae fresh, paralyzed meals. Flexible and adaptable, wasps use their venom not only for hunting, but also as a weapon against rival insects, turning every encounter into a test of strategy and speed. Hidden on leaves and bark, the assassin bug stalks its quarry with patience and precision. This insect uses a needle-like mouthpart to inject venom directly into its prey. The venom is a concoction of digestive enzymes and neurotoxins, breaking down tissues and liquefying the insides of its victims. The assassin bug then drinks its meal, leaving only an empty husk behind. Its strategy is one of stealth and efficiency: strike quickly, neutralize the prey, and disappear before larger predators arrive. These venomous insects are masters of adaptation, using their chemical weaponry for both offense and defense. Their venoms are not just tools for subduing prey, but also shields against a world filled with danger. Each species has evolved its own unique blend, fine-tuned by countless generations to match its environment and survival needs. In the world of insects, venom is the great equalizer. Whether through the agonizing sting of the bullet ant, the paralyzing strike of the wasp, or the dissolving bite of the assassin bug, these tiny hunters remind us that power comes in all sizes, and that nature's most incredible innovations are often found in the smallest creatures. Beneath the emerald canopy of rainforests and along the misty banks of freshwater streams, another group of venomous wonders thrives, amphibians whose vibrant colors conceal a world of chemical secrets. Here, survival is a matter of chemistry, and some of nature's most stunning creatures wield toxins more potent than many predators could ever muster. Among the most famous are the poison dart frogs of Central and South America. Draped in radiant hues, electric blue, fiery orange, and neon yellow, these tiny frogs warn would-be attackers with their striking appearance. Their skin secretes potent alkaloid toxins, including batrachotoxin, a compound so deadly it can halt nerve signals and paralyze the muscles of any predator that dares to bite. Just a fraction of this toxin can incapacitate much larger animals, making the poisoned dart frog virtually untouchable in its lush competitive habitat. These alkaloids are not produced by the frogs themselves, but are accumulated from their diet of ants, mites, and other small invertebrates, transforming each meal into a chemical shield. Travel north to the cool, damp forests of North America, and you'll find the rough-skinned newt. Its unassuming appearance belies a remarkable defense: skin glands loaded with tetrodotoxin, a neurotoxin so powerful that even a small dose can be lethal. This toxin targets the nervous system, blocking signals and causing rapid paralysis in predators. The newt's bold coloration and slow movements are a warning to all. Its flesh is off-limits. Over time, an evolutionary arms race has emerged between newts and their only significant predator, the garter snake, which has developed resistance to the toxin, an extraordinary example of adaptation and counter-adaptation in nature. For both poison dart frogs and newts, chemical defenses have provided a unique evolutionary advantage. Unable to run or fight, These amphibians rely on their potent toxins to deter predators, carve out safe territories, and thrive in diverse habitats, from rainforest floors to temperate woodlands. Their vivid colors serve as honest advertisements, nature's way of saying, danger inside. In the silent world of amphibians, venom is not just a weapon, it is a masterpiece of natural selection. Each brightly colored skin, each toxic secretion, is a testament to the power of adaptation and the endless ingenuity of life. Venom did not appear overnight. Its story is one of millions of years of gradual change, trial and error, and relentless competition. Across Earth's vast history, venom has independently evolved in a dazzling array of creatures, from ancient sea snails and centipedes to snakes, spiders, and even some mammals. But how does such a complex weapon come to be? It all begins with proteins. In the distant past, certain animals developed simple digestive enzymes or antimicrobial compounds in their saliva or skin. Over generations, natural selection favored small tweaks, mutations that made these chemicals more potent, more specialized, or better delivered. As prey and predators competed in an endless arms race, some proteins became toxins, capable of immobilizing, killing, or deterring enemies and competitors. Take snakes, for example. Early snake ancestors may have used mild toxins for subduing prey. Over millions of years, these chemicals diversified. Today, some snakes wield hemotoxins that destroy blood cells, while others use neurotoxins to shut down nerves and muscles in seconds. Each type of venom matches the snake's hunting style. Pit vipers track warm-blooded prey, while cobras and mambas rely on speed and precision. Venom evolution isn't limited to reptiles. Cone snails, slow-moving hunters of the sea, evolved a cocktail of fast-acting toxins to paralyze fish in an instant. Spiders spin venom tailored to the nervous systems of their insect prey, while platypuses, one of the few venomous mammals, use venomous spurs to compete with rivals during breeding season. What drives this diversity? The answer lies in adaptation. As prey animals develop resistance or new defenses, predators must innovate or risk starvation. This evolutionary tug-of-war creates an ever-changing landscape of chemical warfare. Some species, like the garter snake and the rough-skinned newt, are locked in a cycle of escalation, each generation more toxic or more resistant than the last. Venom is more than a weapon. It is a living record of adaptation, a testament to the creativity of evolution. From rainforest floors to coral reefs, the story of venom reveals nature's endless capacity for innovation and the delicate balance that sustains life on our planet. Venom is more than just a weapon for survival. It's a silent architect, shaping the food webs that knit together entire ecosystems. In the wild, every drop of venom influences who eats, who gets eaten, and how energy flows through the web of life. When a predator like the Gaboon viper strikes, its venom ensures a swift, efficient hunt, allowing the snake to conserve energy and avoid dangerous struggles with prey. But the story doesn't end there. The presence of venomous predators keeps prey populations in check, preventing overgrazing or depletion of plants and smaller animals. This balance ripples outward, influencing everything from insect numbers to the growth of plants and the health of entire forests. Venom also drives a constant back and forth between hunters and the hunted. Prey animals develop resistance, warning colors, or lightning-fast reflexes. In turn, predators evolve new toxins or smarter hunting strategies. This dynamic, known as coevolution, fuels biodiversity, encouraging a rich variety of life to thrive in every corner of the world. Even scavengers and decomposers benefit from venom's role. When a venomous animal brings down its prey, leftovers feed countless other creatures, from insects to birds and microbes. Venom, in this way, becomes a tool not just for survival, but for sharing life's resources across the ecosystem. From the savannas of Africa to the depths of the ocean, venom shapes who lives, who dies, and how nature's balance is maintained. It's a reminder that even the deadliest adaptations can serve a greater purpose, ensuring the health and harmony of life on Earth.